In a world supporting a population of over 7 billion people, and more coming in all the time at a rate of about 250,000 a day, and all of them wanting power, the need for alternative sources that are both clean and friendly to us and the world become more and more important with every passing day. We're going to explore some of the main technologies used to harness alternative power and some of the leading technologies, some of the leading devices being developed today. The question comes up quite often, why do we need it? What's the big deal about? We need it for lots of reasons, mainly because the way we're going right now with the burning of the fossil fuels is putting out carbon emissions in the atmosphere and back into the world's ecosystem. And that will really have more of a detrimental effect on humanity far before we actually run out of those carbons to burn. Renewable energies make up only 11% of the power the world uses in 1 year. That works out to about 1.95 terawatts. Now, that may only be 11%, but you put this in perspective, it's a whole lot of energy. 1.9 terawatts could power a single 100-watt light bulb for well over 2 million years. That's a lot of power. Our population's increasing as we start to move out of our more traditional ways of energy harvesting through carbon-based fossil fuels and other such means. We look for the alternative sources that are abundant and clean, reliable and cheap. And of these sources right now, the sun still remains a major player. What's interesting to know is the sun releases in potential energy, potential, on the surface of our planet, more energy in 1 hour than the entire human race uses in an entire year. So, all we need to do is figure out a way to tap into this in a more conducive manner than we are now, and we really are in the money. Solar is amazing in that it produces no pollutants whatsoever. It's almost always available, as most of us are pretty sure the sun is going to come up tomorrow. Yes, it is dependent a bit on solar radiation levels on the planet, at which point, which time, and which place. But for the most part, solar is going to be around. It is renewable, it is low maintenance, and extremely reliable. So we know alternative sources of energy are out there. So the first actual transparent solar glass, pretty cool stuff. Designed by researchers at Michigan State University, this is the first truly transparent solar material. Not murky or foggy like other transparent, quote-unquote, solar materials have been in the past. This one actually allows all visible light to pass right through it, and still makes electricity out of sunlight, which is kind of an oxymoron. In the past, generally, if you're going to take light and make electricity from it, you have to absorb the light first. This does the same thing, but only in lights that are invisible to the human eye. So it traps the infrareds and ultraviolets while allowing visible light to pass right through it. Pretty neat. They expect this stuff to be used in the building of skyscrapers for windows, covering signposts along the freeways, cell phones, and laptops along the way. So we'll see where this goes. Definitely something to keep our eye out on. As time goes on, we should start seeing a whole lot more of this. Personal devices built and designed specifically to be charged off the sun. This one here is a laptop built by a company named Seoul out of Canada. And this laptop is designed mainly for military use at this point, but also in mind for developing countries and communities and places in such rural conditions that internet or power just to plug in and charge your batteries is out of the question. Imagine how freeing something like this could be. Take your laptop wherever, your information, wherever you need to go, and all you need with you is a sun. Forget the cables and the chargers and the USBs. Pretty amazing. So this could really do a lot to change the development of countries that need information, need power, but don't have a way to get it right now. I'm excited to see where this goes. Of the current viable alternative sources of energy we have today, the sun is just one. Wind is another one. We, the human race, have been using the wind power for over 4,000 years. Not only has it been to generate power as it does today, back in the day it was mainly just to grind up our wheat so we could make bread. However, we've realized and recognized it as a viable source of energy for quite some time. To that end, Oregon right now has the second largest wind farm in the world. I thought that was pretty cool, being that this is our state. You know, the first largest is in California, and I believe the third is in Spain. But the second largest, Shepherd's Flat in eastern Oregon, generates a worthy 845 megawatts of power annually. That's quite a bit. The efficiency in the technology has increased quite a bit in the last little while. 15% in 25 years. And every day we go through, the innovations in design for harnessing wind power are quite mind-blowing, actually. They're all over the place. Right now the U.S. has 61,100 megawatts of wind power generating capability. Now, the thing with wind is it isn't as reliable as sun. Obviously the wind comes and goes, it gusts, it goes fast, it goes slow. So all we can do is put these wind turbines in places where we hope it'll work, and for the most part it does. But the idea is to harness more wind, faster wind, better, more reliably, so that the power we can generate from this becomes really substantial. And we're going to see some of these ways here. Wind turbines have been around for quite some time. They're one of the best technologies we have at this point for harnessing power from the wind. The problem is they have to be attached to the ground. Being attached to the ground, the wind at ground level tends to be gusty and at best not too reliable. So the idea here is to create a wind turbine that can float in the air. The higher you get, the stronger the wind. The more wind power we can harness, the more electricity we can make. 2, if it's not attached to the ground, it doesn't need to be spread out to avoid wind turbulence from one blade to the next or one tower to the next. These things can be deployed literally anywhere, just with a string to the ground holding it in place, and can get pretty high and grab a lot of electricity. So we should be seeing a whole lot of these or ideas like this come to fruition here in the future. Another twist on the traditional wind turbine is this guy, a bladeless wind turbine, based on an idea kind of off of a sailboat apparently. The idea here is that it uses a thin membrane and moves back and forth with the pulsing of the wind. They're 45% less expensive to make and more than twice as efficient as traditional bladed wind turbines. So pretty exciting. We'll see some of these coming out too. This one, wind stalks. We think of a wind turbine. Okay, the problem there is that wind turbines have to be spread out. As the wind passes through the blades of one turbine, it becomes turbulent and creates a funnel of turbulence. And the second or third wind turbines cannot be placed in a path of this turbulence. So it requires a whole lot of space. You need to spread out towers quite a bit to make them actually worthwhile. Wind stalks take that completely out of the equation. Wind stalks utilize the chaos and turbulence of the winds. And each one of these little sticks you see here in the picture can generate as much electricity as a single traditional wind turbine. Pretty amazing. So we've got sun, we've got wind, and coming up next is water. Hydropower is actually the leading source of renewable energy in the United States today. It accounts for about 20% of all energy generated in the entire world, which is pretty good for a renewable source. It is the most efficient way of generating power. It's highly adaptable to diverse conditions. What that means is anywhere there is running water, we can gain power from it. Okay, we can utilize devices that harness electricity for moving water, whether that water is in a pipe in our cities' streets, whether that's in a stream, whether it's literally at the bottom of the ocean. If water is moving, we can get electricity from it. Another positive thing about it is it's an incredibly clean source of alternative energy. As far as devices or inventions go, this is one of my favorites. Now, this one, it could have easily been placed under the solar or under wind, but I chose to place it underwater for a specific reason. Now, this is what they call a wind tower or a downdraft tower. It uses a combination of its shape, solar heat, in that the solar rays heat and dry the surrounding air, okay? And lots of water to create wind. The wind is then harnessed at the bottom of this tower through wind tunnels, basically, and turbines to produce electricity. Now, I put this in water because, as it says, lots of water to create wind. Basically, how this works is at the top of this hollow tube, water is shot into the opening, into this dry, hot air. The water absorbs, creating cold, heavy air. That heavy air sinks to a tune of about 50 miles an hour and then is directed out through these turbines at the base of the tower. In order to make this work, there requires, for a tower about the size of what you're looking at here, requires 41 tons of water per second. So, that's a lot of water. But it also creates a whole lot of energy. Another amazing innovation is what we're calling the power pipes. You know, we have all this running water in the systems of our cities and our sewers and waterways and pipes. Why not figure out a way to tap into this continually moving water and harness it for electricity? Well, that's exactly what these folks have done. They've tapped into the kinetic energy of moving water to create electricity via these pipes with integrated generators and turbines. Amazing idea, something I'd like to see personally in every city built. Wave motion is yet another upcoming technology being looked at all around the world, in fact. Another reason I love Oregon. Here's Oregon, okay? This buoy that you're looking at right now is one of 10 planned to be installed off the coast of Reedsport, Oregon. Oregon actually started an initiative a couple years ago to create a utility-scale wave farm. And the devices that they used were built in Canada, and unfortunately one sank. So kind of set the project back a little bit. Here we go again. This, what you're looking at, is the first of 9 planned being installed as we speak off the coast of Oregon to generate power from the waves. Pretty amazing. As we transition from more of the well-known sources of alternative energy, the sun, the wind, the water, we come upon bioenergy. Bio can be a whole lot of things. It can be the biofuels that we get from burning the waste from feedstocks and forest debris. It can also mean the biological side of technology, using various biological resources such as bacteria or viruses to change different plants into different things we need. We'll cover some of this. Right now, bioenergy accounts for about 1.4 of all power generated in the United States. It's not a whole lot. Renewable bioenergy is second only to hydro for the current energy production. Okay, right now biofuels utilize about 68.8 million tons of what they consider to be forest debris. In all actuality, that's the forest industry too. You know, cutting trees to burn for fuel. Energy production is not affected by the weather. Okay, we can burn trees and burn trash at any point during the day or night. So that's nice, it's reliable, but it is an extremely high cost of production. Main reason for this is biofuels are not dense. Okay, it takes a whole lot of trucks to truck enough fuel from the forest to a bioplant to have that stuff burnt to make any reasonable amount of electricity. So there's a high cost associated. One of the coolest biological-based technologies coming to the forefront of science today is algae, believe it or not. Doesn't sound that entertaining, but it actually is pretty cool stuff. Algae, come to find out, can be grown on land that we otherwise can't use for any purpose. We can't live on, can't grow food on, so can't use. But we can use it to grow algae. The water required to grow algae can be water that is unfit for human consumption. So basically, we can use all of our waste stuff, waste land and waste water, to create a product that we can use to burn in our biofuel plants and make electricity from. How cool is that? The other nice thing is these ponds, these places where the algae is being grown, are great absorbers of CO2. So here we are throwing out all the CO2, carbon emissions into the atmosphere. Well, this stuff can help take it back out. Hopefully we see more of this coming up in the future. Another groundbreaking, sort of mind-boggling science is using plants to create solar cells. And this is like I say, is groundbreaking right now. But what science is doing, they're using a retrovirus to basically infect the cells of plants, specifically tobacco plants. These infected cells transform themselves into working solar cells. Okay, the plant is then cut down, dissolved into a solution. The special cells that were created are then harvested out of this solution, condensed, and then can be applied to any substrate. Basically, you can spray these cells on glass, on plastic, on whatever, and voila, you have a working solar panel. Doesn't last as long, but it is cheap and makes electricity, and how cool is that? So another cool one is bacteria. Bacteria, small little things that it are, have amazing potential for electricity and energy production. Here we see a little petri dish with some sort of super bacteria in it, and this bacteria is used successfully to convert CO2 into liquid fuel. This isobutanol is a base for aviation fuel. So, convert CO2. Here's the stuff that's damaging our ozone, our Earth, and we can use it to create fuel. Pretty amazing. I'd like to see some of this coming up too. Alternative energy technologies are really the way that this world is going to find to survive into the far future. We have endless possibilities and a fascinating potential of alternative technologies out there to use. There's a huge growth in it right now, and of all the ways that we can gain power to support our life and our planet, alternative sources, renewable sources, clean sources are the only sources that are both friendly to us and our world that we live on. Let's do our part, each one of us, to make sure that this is the world in which we all live. Thank you for watching.